Is the microphone working? Okay. My name is Eric Wenger. I work at a company called Applied Research Associates. It's a local company. We do a lot of government research and development work. I've worked since I started there. I've told people it's one of the coolest jobs I've ever had. Since I started working there, I've worked on a DARPA program and an IARPA program. And I want to tell you a little bit about what we've been doing what I've been working on the last year and a half at ARA, taking our system called Waldo from a cluster to the cloud. This is our acknowledgement to our sponsors. I've put all the slides up. I'm going to go quick past a couple of these things. The short thing is it's a cool company, and the other thing is we're hiring a lot of people right now, and almost all the work we do is geospatial in some way or another. The Waldo system is a semi-automated geolocation system. So we take ground-level imagery, videos from somewhere in the world, and we try to figure out where the person was when they took the picture. So we do Waldo is kind of the Where's Waldo thing. Carmen Santiago is another name that came up. We're operating in areas that are something like we started off in 10,000 square kilometer areas, which is the size of LA, the LA metropolitan area. We moved up to 50,000 square kilometers, which would be more like the first one would be the Los Angeles metro itself, and then if 50,000 square kilometers is a little bit like the entire kind of SoCal metro area, LA and Orange County and Riverside and those things. And now we're operating on a 500,000 square kilometer area, which is a good chunk of the state of California. But we're operating we've got a bunch of test data from different parts of the world, so we operate in a lot of different kinds of environments. We have the awesome thing about this project is that the government gave us they've given us 30 terabytes of digital globe imagery to play with. So we just have huge amounts of data that we can play with and see how it works and see what it does. We'll be talking about some of the different ways. Some of my other teammates are talking about how they're using that data at other presentations. We're building stereo height maps, multiview height maps, doing 2-meter land cover classifications, things like that. All in the idea of trying to build up a database where we can search for these potential locations of images. It's a fun project, and it's competitive like any kind of a research project is these days. We have these big tests where we compete with other teams to see how many of these pictures we can find. We use a lot of free and open source software. The slide's kind of lame, but so when I started on the project, I had no idea how to open a GeoTIFF. So I mean, I didn't even. Somebody gave me this stuff, and the whole team left town when I got onto the project. Everybody else went off to some meeting, and they said, figure this out. So I didn't even know how to open a GeoTIFF. So what did I do? I found QGIS. Well, now most of my team is using QGIS, and some of them are writing plugins for QGIS for the kind of the research projects we're doing. We're using, obviously, GDAL and Ogre. We've always used that. Postgres, PostGIS, Python. Kind of a neat tool called Luigi that Spotify built. We use a lot of OpenCV. I like the Orfeo toolbox for a lot of things. There's a lot of other libraries we're using. So this project leverages a lot of free and open source software. So I want to talk to you primarily about what we learned moving Waldo from a cluster to the cloud. So we took Waldo from this little cluster right here, sitting in an abandoned office on our floor, which was kind of a neat cluster. It was five nodes, 84 cores, 736 gigs of RAM, 135 terabytes of storage there, all running Windows in the Microsoft HPC pack, and we ran C# and MATLAB code when I got to the project. So when I got there, the government asked us, they said, in the last year of the program, we'd like you to run everything on Amazon, preferably on Linux. The reason for this, we kind of have learned over time, is that we're doing really well. The program's going really well, and they want us to transition this up into the government, into other agencies, and so they need us to be not running in Windows anymore. So I've been using Linux since Slackware 1.0 or 1.1 when I shoved 20 floppies into my 486. So I thought, this sounds like great fun. Let's do it. And so it wasn't nearly as easy or smooth as I thought it was. So I want to tell you a little bit about some of the hiccups we ran into. So maybe if you start thinking about taking a project onto AWS, you might know what to run, some of the things to run into. First, I want to start off, I thought I was a little bit negative with my presentation. So I want to tell you the first thing. AWS does work. We've scaled up our knowledge-based production rates by more than 3x. We've not even tried going up to 50 nodes or 100 nodes in any of our production, but there's no reason we couldn't do that. So I can, if somebody says we need to look at a new area, we can go plug 16, 20, 25 computers in there easily on Amazon and get it done in a few hours instead of a couple of weeks on our cluster. So it does work. We deliver updates to our system in 3 Amazon machine images, which is just awesome. We just package up all of our stuff onto these machine images, and I can just share those with my customers, and I don't have to copy it onto a hard drive, mail it, ship anything, upload anything. It's all done in the cloud on Amazon. And the system is remotely accessible from anywhere. So anybody who wants to use it anywhere they are, they can access it on the web. Log into the system and use it. It's very easy to get started. We got started. We started building nodes. We started making Windows nodes so we could just take our software and put it right onto the cloud just to see what it did, and it worked. We were able to do that. At least it was when we got started. It gets much bigger after you really start to get into it, and it becomes its own kind of IT problem. You start to, now we have probably, I think I looked earlier today, and my team's got 60-some instances running right now, and there's probably 200 or 300 instances total in the system. So you really do have this level of this many computers running, and you have to manage them, and they can get out of control if you let them. So the next thing I'll say is AWS is expensive. We've spent $95,000 in the last 12 months on AWS. We're running about anywhere from $10,000 to $20,000 a month is what our spend rate is on AWS to do this research project. No one from Amazon has ever called me. I think this is the only time I've ever spent monthly. I'm spending $10,000 to $20,000, and I've never talked to a salesperson. And I did not get a free Prime membership. So when we started this, the joke was I put it on my own credit card because I didn't want to. Our IT department didn't know anything about AWS, didn't want to deal with it, so I just put my credit card down and got the account started. Unfortunately, I stopped accruing miles because they told me I couldn't charge more than $5,000 a month, so I had to stop. The other thing here is that it's important. Windows is twice as expensive as Linux. Windows is twice as expensive as Linux on AWS. Every hour you run a Windows instance, it costs you 2x what a Linux instance does. So it gets very expensive. So the parts of our system that we have not converted to Linux are the most expensive parts. On the months where we're testing the search and web front end of our system, which has not been yet converted into Linux, that's the month where I spent $20,000. On a month where we're testing the Linux side of things, I spend $10,000, $12,000. AWS does not come out of the box with idle resource monitoring. It's amazing. They have a wonderful GUI, a wonderful console, but the one thing you cannot do in the console out of the box is to check for idle resources. Surprise, surprise. That's something you're going to have to figure out how to do yourself because idle instances can cost a lot of money. If somebody leaves a cluster of 12 machines running over the weekend, especially Windows instances, that's going to be a fairly big bill on Monday morning. And stopped instances can cost too. A couple months ago, I left 33 instances running because I wanted to collect some statistics on them post-mortem. And I left them running for about 2 weeks. Well, they were 200 gigs each, and that turned out to be about $600 just to leave some instances stopped, not consuming CPU time for about 2.5 weeks. So you got to watch a lot of things. So what I'd recommend is, if you get started in there, using tags to track your instances. Start that early. You define your tags up front, figure out how you're going to split things up, and then tag every instance as you create it. What would be really nice is if resource tags could be implemented as a policy. So if every time a user created an instance, it would be automatically tagged with a resource tag, that'd be awesome, because then I could just make sure that everybody in this group of people tag things with this project's tag, and everybody in that group of people would tag things with that project's tag. Can't do that, but we limp along. You should plan to write some custom code, in particular to monitor your spend, to look for idle instances. There's tons of data to do this. So one thing, so that even though you cannot get an idle instance monitor in the console automatically, they do provide you tons and tons of logging information. If you could write Hadoop code or MongoDB code, they have just tons and tons of CSV files in there. It'd be very easy to find all of your stats, to look for everything, to account for everything in the system. It's just not, there's just no easy button. Another thing I'd recommend is to locate and pay for a service. I have not done that yet. I haven't had time to find one. This is a research project, so we spend, we endeavor to spend more time doing research than we do on the implementation, but I'd encourage you to find a service. I'll bet there's one out there that's not too bad that could monitor and optimize things on AWS for you. S3 is unreliable. I didn't really expect this when I got started, and it's caused us a lot of problems. If you accumulate all the problems that this has caused us over time, it's actually expected. It's expected. I wouldn't say that I should. I shouldn't have been blindsided by this, but it did affect us quite a lot. It doesn't, S3 is an object store, and it's based on HTTP principles. It doesn't have to work every time. I should have retries and things like that in my code. I should be robust to that kind of stuff underneath. A lot of the people on my team, though, since they're used to writing research code, don't implement robustness in their code. There's no state machines, nothing like that to keep track of those things. So I'd say that when you call AWS S3 sync and sync a bunch of data from S3 down to a local instance, it doesn't always work. It'll always return a normal error code. You always get a 0 back. It doesn't always work. It doesn't check checksums. So if it does think that it worked, it copied some file down, the timestamps now match, but the file sizes are different, or the data got corrupted somehow, there's no way for AWS CLI to do that. There's a tool out there called S3 command that does do that, but it doesn't work on Windows. S3FS is a really neat looking tool that's out there. It lets you mount S3 as a file system on a Linux node. It looks really, really neat. Don't use it. Don't use it. It frequently will go looking through a system and find 0-byte files as we copy them out of there. It's another one of these things that says that it succeeded, and it does not succeed. It doesn't check what it's doing underneath. Several people on our team have tried to use it because the use case is just perfect for S3FS, and we've had to rip all that code out and rewrite it underneath to make sure that we get rid of that because it just is not robust. So my recommendations, Occam's solution is to always sync thrice. That's what we came up with. It was a really easy solution. Every time we sync data down, we sync 3 times, and by the 3rd time, you almost always get all the data. And if you think I'm crazy, we had a phone call with our teammates, some of the opposing team that we're working with, or against, I guess, depending how you see it. They found the same solution. So they found the same thing, that you sync once and it doesn't always work. If you sync a second time, it almost always catches everything. So we decided to sync everything 3 times. So it doesn't cost a lot. It's an easy implementation. It keeps us focused on research, and it works. On Linux, S3 command is great because it will check the checksums. It will make sure that it works like rsync, and that it'll check to see what the MD5 sum is on the S3 object. It'll compare it to what's on disk. It tells you that your data is actually copied correctly. I'd recommend using Boto 3, and we're doing this right now by ourselves, to roll your own sync command. Figure out how you need it to work for your system, and write your own using the APIs. Because that's going to be the best thing to do. Better yet is to make a key database. So one thing about S3 some other things we learned about S3 going along were that in S3, a key lookup takes quite a bit of time. So when you ask for a file, it takes a little bit of time. And if you ask for 20,000 files, and for each one you ask for its URL, it takes a lot of time, especially if there's a lot of network latency at the time. So one thing you can do is, a lot of the people who are more well-equipped than we are right now, is that you put a SQLite database, Spatialite database in the root folder of your bucket. You load that into your instance, and you use that to figure out what your URLs are. It's a lot faster lookups than letting the S3 API look it up. Again, don't use S3FS. The other thing, The other thing I'll point out, and I think I might have made of this later in my presentation, but S3 is not a S3 is not a file system. If you take a giant file tree and you upload it to S3 with all your directories and hierarchy and everything in there, it will not perform optimally. Each bucket has a limit, and and the system is in its entirety is load balanced using a hash of the file names. In particular, it's a hash of the first few characters of the file name. So if you put everything in one big directory in your S3 bucket, it will all reside on one server, and you'll not take advantage of the load balancing inside AWS. So consider performance at scale. So what happened here is I did a lot of testing on various things. Is EBS or S3 the right thing for a certain use case? Do I use my block storage or object storage? And a lot of times we'd say that, well, S3 looks like it's working just fine. Everything works great. EBS looks like it's actually slower, or it varies enough that we say it's slower. It's got some IOPS limitation at some point that makes it look like we should just use S3 for it. When we looked at it closer, that looks fine when you're looking on one instance. When you scale up to 20 or 50 nodes, then there are other problems. Some of those are that if you've got a VPC and a NAT router in your VPC, virtual private network, all the data, even to S3, transits your NAT instance. So that instance, for example, when we first started out, I didn't realize this. I asked somebody on the team to set up a NAT instance. He set it all up, and I was happy. Check that off, and it's all working great. Turned out that node only had 100 megabit per second, 200 megabit per second access, and so when we were running on large clusters, we were getting throttled. We were throttling ourselves through our NAT instance. On top of that, S3 buckets have rate limits. So every S3 bucket has a 300 get per second and 100 put per second rate limit. So if you put all of your 30 terabytes of digital globe imagery in one bucket, then all of your nodes have to share that rate limitation, and they all go through your NAT instance. So the best thing to do would be I would recommend splitting things out by geography or in some other way. S3 buckets use, like I said earlier, they use key hashes for load balancing. So you can't treat it just like a file store. EBS has limits, so there are problems with IOPS. For example, I'll go into more detail in another slide, but anytime your IOPS goes too high, then you get throttled on EBS because the standard EBS volume has a pretty limited IOPS compared to what you'd see on a local machine. The number of I/O transactions per second out to the disk. You can fix that by buying provisioned I/O, but on one of our instances, we had a large Postgres installation on one of our instances, and that was costing us on the order of $50 a day to pay for having provisioned IOPS on that instance to support that database operation. So, like I said earlier, we now have, in most of our cases, we distribute our data across a lot of different spaces. We haven't done this with our buckets yet because we are working with other groups and we haven't been able to do it. But in general, we distribute all of our data across like MGRS grids. So we'll start off at MGRS grids, and we'll subdivide things into 1 degree by 1 degree and even smaller increments if we need to keep the data manageable at each level. And I would totally recommend doing that with putting any large amount of geospatial data into S3. I'd recommend using a database, again, for the same reason I mentioned earlier, that the network latency and the key lookup is substantial, especially if you have a lot of small files in S3. Use ephemeral disks for temp volumes. Now, this is where we got into a big IOPS problem. When we first got started, we were decompressing NITF imagery into GeoTIFF so that we could do neural network classifications on it. And GDAL Translate was the tool we decided to use to do that. So this thing was taking on the order of maybe an hour to decompress a NITF image. We couldn't really, what's going on here? And we spent probably 2 weeks dealing with this and a bunch of other issues that we were having at the time. Well, it turns out that GDAL Translate has a surreptitious, what I would call a surreptitious little function in it. It creates a set of about 8 temp files, and then it promptly unlinks them. So you can't ever see that they existed unless you strace through everything, which I ended up doing. It creates these giant temp files to store the data that it's translating out of from NIDIF from one format to the other. Well, it creates them by creating the file, and then it seeks to a very large number, which is an instantaneous spike in your IOPS, which gets completely throttled by Amazon at the same time, and you end up taking an hour to get your to translate an image because this temp file process is getting throttled. And all the while, you can't find the temp files because they're unlinked immediately, so you can't see them in the file system. So I would love it if GDAL Translate was more upfront about that kind of stuff. So what I'd recommend is we now use instances that have ephemeral disks, local SSDs on the physical instance where your instance is running, on the physical node where your instance is running. We map /temp to those ephemeral disks so that things like GDAL Translate and other tools don't get throttled at that point, and that works great. And another thing that is a neat trick that some of our teammates have used, we haven't fully got this into our system yet, use pre-provisioned EBS snapshots. So we have a knowledge base when we're searching all of these, let's say searching a 500,000 square kilometer area, we have a 70 gigabyte knowledge base that needs to go onto every search node. We currently have been running, the way we do it right now is we sync from S3, we sync that 70 gigabyte data structure down from S3 onto each of the nodes. A much better way to do it would be to programmatically make an EBS snapshot and then attach that snapshot to every instance in the cluster. Then every instance has now its own essentially parallel path to its own data, and it's a much faster way to distribute things. It's been very successful for one of our teammates, it's VSI, that's speaking tomorrow. The security is really well done in AWS. It's very, very complex. It's so complex that it's really time-consuming to try to figure out. So my system, I'd say, is probably not that secure, but it works for us. Use a VPC to protect your data, and remember that all the data transits the NAT, so you have to size it accordingly. If you look in AWS, you'll see that each kind of instance type has a different level of network connectivity. So I'm up to a place now where our NAT router has a 1 gigabit per second network connection, and that works pretty well for us. It's a good trade-off of speed. You can get the C38X large instances that have a 10 gigabit per second network. You can also pay Amazon for one of their VPC NAT nodes. I can't remember what they're called right now, but they're quite expensive, but the data rate's almost unlimited in those. Remember, if you're working on a sensitive project, VPC data is encrypted. It's not encrypted, it's just segregated. The user permissions, IAM permissions, are very fine-grained, and they're very difficult to manage. There are hundreds and hundreds of different kinds of permissions you can give to each user for each resource that you're using. They're all coded up in JSON. It's very, very flexible, but it's very, very difficult to manage. It's a lot like if you're trying to be very strict with SE Linux, it's very difficult to keep track of all of these different permissions and where they're going. Snapshot all of your important instances frequently. Snapshots don't cost much. They're compressed. They're differential. They don't take. Amazon doesn't say exactly how it works, but they're very low cost. They're very low volume compared to the data you're snapshotting. And use termination protection. So if you have a bunch of people working on the same Amazon account, one of them invariably will shift-click on somebody else's node and terminate it if you don't protect them. So please remember to use termination protection so that you can't just automatically terminate or accidentally terminate somebody else's instance in the console. That's happened a few times, and we got through it. It was a painful lesson. Sorry. All right. A couple of remaining thoughts that I have. Users need to know Linux and be comfortable with the command line. So we're delivering something on Linux. I've got a team of people who all have been doing Windows and Visual Studio development for the last 10 years. That is difficult. It's been I've tried to support people and educate people as much as I can, but it's really is a difficult thing. You should have a plan to teach people if you are going to do something like that. If you've got a bunch of users who aren't familiar with logging into a remote system and doing all of their work remotely, you should have a plan to teach them. I didn't. I still would like to hear anybody who's got a good plan for how to teach a bunch of people how to become comfortable with the Linux command line. When I first envisioned this entire thing, the whole thing in my head was in Hadoop. It was all a glorious Hadoop Spark project, and everything. All the data was located on the node on nodes and the processes were running on the nodes where you wanted it to, where the data existed. It really is quite a lot harder than webinars make it look. It looks really easy to get started. You play with it. To transition an entire system that way, and with users who don't know Linux, it's quite hard. So we have not made it there yet. If you do need to do that, plan to spend substantial time and money to get there. It's not an easy transition. It's easy to get some little demos set up, but it's not easy to get your whole system running that way. And avoid cloud lock-in. We didn't. So my system right now, as it is, only runs on Amazon. It's only going to run on a system that's got an AWS API, which is okay, but I cannot, at this point, take my code and run it on our local cluster anymore because it's got S3:// embedded in places all throughout it. I would strongly recommend spending some time up front if you can eke it out and avoid that. Apache libcloud looks really interesting. You guys have seen that. It's a very neat looking abstraction library in Python that lets you use anything from OpenStack, Google, Azure, or AWS with the same API. So where are we going next? I'd really like to go to using Docker, using containers. I think that's the best way to go, and our customers are really very much into that. I was telling somebody at Red Hat the other day, I was in a customer meeting, and I mentioned I used the term container, not to mean Docker, but just to describe the concept of containerizing something. And the entire room looked at me and says, "Are you using Docker?" And I'm like, I wish I was. So definitely want to be using things like Hadoop, Spark, GeoWave to do big data, because the area we're operating in right now is 500,000 square kilometers. The world is 140 million square kilometers. This is a very small. We're looking at a very small area right now. If we want to go up to, if we really want to look in do geolocation in large areas, we need to go there. We're going to be looking at deep learning. Google's done a demonstration recently showing how their deep learning system could geolocate photographs down to the continent with pretty good accuracy, much better than humans. And our entire visualization backend, how do we, once we find a potential location, how do we show a user, well, is this really the location? We want to render imagery on DEM and present a Google Earth style photograph. I'm pretty enamored with Cesium right now, looking at what they're doing, and it looks like an excellent system for doing that kind of thing. We have a couple of other talks, like I mentioned. Today at 5:20, VSI is going to be doing a talk on fully automated DEM generation using satellite imagery. So they're taking the 30 terabytes of satellite imagery that we've got sitting out on AWS for our project. They index all of that. We give them a shapefile that says we want a DSM, a height map for this area, for this, let's say, an urban area. They will figure out which imagery is available, pull it all in, and create a multi-view height map from that imagery. And they'll be talking about that. And my colleague Craig Stutz here at ARA will be talking tomorrow at 11:15 on automated high-resolution landcover generation from worldview multispectral imagery. So we're doing kind of a custom neural network classification at the 2-meter level using worldview 2 8-band imagery and worldview 2 and 3 8-band imagery, which has worked really well for our system. And that's all I've got. Do you have any questions? Yes. Thank you.
So in terms of your staff that work with you, how was the transition from moving to Windows to a Linux environment? Like in terms of, we always talk about the learning curve for staff, for instance. What was your experience?
It was good it's good up to a level. What's that? What's that? Oh, sorry. The question was, what was the learning curve like for the Windows-based staff that were transitioning onto this Linux-based AWS project? Everybody learned we got everybody up and running very quickly on basic operations in Linux. We got everybody so that they could log in, they could run their code, they could do the bare minimum. The place where it really gets difficult is when they're getting in there and trying to debug something remotely. There's a lot of tools that I know how to use natively. When I, if I'm looking through a set of log files, I know regular expressions like the back of my hand. I can grep out something. I can grep out a very complex thing and look for something in the system. The folks on the team, that's the stuff that's really hard to teach people, how to be really proficient in that kind of thing and work very, very adeptly in that environment. So it was not that bad getting everybody to the point where they could do their work, but to do it really quickly and as effectively as they would on a local system, we're not there yet. So, yeah.
Being the Red Hat guy in the room, I have a comment.
Yes.
I have a question. The comment is, of course, we should have them all running Linux laptops. They should just eat and consume Linux all the time. Then it would be easier for them. I would recommend a particular brand of Red Hat.
I understand.
So then the question is, how do you deal with moving all the data in and out of this system? Are you using like their ship a disk system? Is that basically what you do?
So the question, I'm just going to repeat, the question was how do we get the data in and out of AWS? And yes, we are using the ship a disk system. So there are in this last year, this program started out with 4 competitors. In the last year, there are only two competing teams left. If you watch these DARPA and IRPA programs, you get weeded out over the years. And there's also a test and evaluation partner. That team, the test and evaluation team, shipped hard drive, 4 terabyte, a stack of 4 terabyte hard drives to Amazon. Amazon loaded those into the system, and that's how we got the data there. What I'd love to try out later this year is using DigitalGlobe's system where they've now got all of their data out on S3 so that you can actually get access to it through some account. And I'd love to play with that. If there's anybody from DigitalGlobe who knows about that, come talk to me. I probably can fund it. Yes?
So I work at DigitalGlobe.
Okay.
The platform you're talking about is the geospatial big data platform.
Okay.
If you're interested in looking it up, anybody here is GDBX.
GDBX is that platform so there was a question over here. Yes.
Platform that had everything you need, and then have you considered other things like Google Cloud Platform or Azure prior to?
We were required. Oh, stand close to the microphone, to the speaker. The question was AWS the best fit, or have we looked at it? Have we looked at Google Cloud, Azure, or any other cloud system? The answer is that we were required to use AWS for this. So the government has. I won't go into it too detailed right now, but the government has other AWS implementations using that API. So it's best for us to stick with AWS so we can move into GovCloud and then other systems that are all compatible with that API. Yes.
Did you have to deal with I/O issues with such large data sets? I'm finding that's a recurring theme in AWS.
So the question is, do we have to deal with I/O issues with large data sets? And yeah, there's a bunch of things in my talk. The S3 I/O, putting all the 30 terabytes in one bucket was a really bad idea. We didn't know that at the beginning. I'm not blaming anybody. Yep.
In the context of EBS.
EBS, yes. So like, for example, things like GDAL Translate that were writing stuff out to the temp folder. If your temp folder is sitting on EBS, there's really no way to tell that this is going on except to like look at the graphs and say you've got some giant spike in I/O. But yes, if you're for EBS, for most things it works fine. So
So short of using ephemeral, how do you deal with that?
we actually, by moving the temp folder to ephemeral and any kind of a very sensitive thing, anything that was really I/O bound out to ephemeral operations, and then moving it back into EBS or just pushing it up to S3 from there. That's how we dealt with it. I haven't found a way to deal with it that's not one of those two things. Yes.
So did you migrate most of your code to something like .NET or something else in Linux?
So the question is, did we migrate most of our code from .NET to something else? We are running most of the code that was written in .NET is running in C# now. It's running in Mono, and still running essentially .NET on Linux. If you're curious, it works pretty well. It took me probably from not knowing Mono and not being familiar with that side of things at all. It took me about 2 or 3 weeks to get all of our code up and running in there, to remove all the capitalization errors, which was like probably the most time-consuming thing. Getting all the code running in there was okay, and it's been pretty robust. We have I'd say there's a couple of places where I've had to go find a cherry-pick a patch on Mono to get it to fix a threading issue, but in general, it's worked for us. Any other questions? One more.
So are all your guys still on Visual Studio?
They're mostly still in Visual Studio. I think I'm becoming a big fan of Microsoft's partnership with Canonical so that we can run stuff on Windows, because I've been a Linux person for ages, and there really isn't a development environment that's as good as Visual Studio in Linux. I hate to say it. I look up Eclipse. I try Eclipse every few months, and it's still never. It really isn't as good an environment. So Microsoft's embracing of Linux and open source things in the last few months, I think, is going to be a big deal. A lot of guys are using, for example, the Python tools in Visual Studio to write Python code, and that's working pretty well for folks. One more question back here. So the autoscaling groups would work out for us. It's more of when somebody's doing some test and debug where they start their own group manually because they need to leave it up, or when you're doing development. During runtime, we've got that mostly under control. The system goes up and down, scales up and down very easily. That's right. Yeah. So I think our time's up, and I thank all of you for attending today. Appreciate it.